Alright, this is a big test to see if those gate drivers chips are still working. But I'm testing one of the channels on this because there's 4 channels, because there's 4 of them. Got 4 gate drive transformers. Well, they're not gate drive transformers, they're transformers that power the gate drivers. There are 4 isolated supplies, then there's 4 rectifiers and capacitors smoothed out. Get 18 volts, or around about 18 volts. Then there's the oscillator circuit down there with a CD4046 chip on there. Each one of these gate drive chips costs £5 each, so it's like £20 there. Then that's about £1. Then this circuit here is about £1, and then these RGBTs cost quite a bit as well. So there's quite a lot to go. There's about £50 to £75 here. They could just go banging, but it's not going to go bang, of course, because it's like all fused in there and low voltage at the moment. I'm not putting not putting the high power into the RGBTs yet. I'm just testing what's going into the RGBTs, the RGBT's gate. That's what I'm testing. Well, actually, it's an RGBT, so it is. I think it's gate collector emitter. Yeah, so it's gate. What's going into the gate of the RGBTs, and that channel there, channel B, is not connected to anything at the moment. I've just got channel A connected to one of the RGBT's gates, and I'm going to plug it in now. I've got the variac there for when I test the full power thing of it, so this video is going to be quite a lot in it. Hopefully the camera won't run out of memory. Hopefully the camera won't. Right, okay, plugging in. There we go. Lights turned on. Those are oscillating. Each one of those lights are oscillating about 150 kilohertz. Oh yes, it is doing something. Let's have a look at the trigger on this. Turn it up a bit. Stupid trigger. Okay, because there's only 18 volts going into this, I'm going to feel how warm these are. Stone cold. Excellent. Can't hear any high pitch noise. Oh yeah, of course, because it's 100 and something kilohertz. But oh yeah, I can hear high pitch noise. It's the oscilloscope trying to focus into it. Right. Oh, almost. Actually, I'm gonna change the frequency of this until it focuses alright. Oh yes, there we go. I'm gonna. This is so stupid, this thing. Ooh, and the higher the frequency, the lower the voltage gets. It's harder for it to switch. So I think I need a bit more current. Oh, there we go. We've got something there. That's probably going about. That's still ultrasonic, probably. I'm going to pause this video until I get it focused, and I'm probably going to connect the second channel as well to see if it's inverted. Alright, we have success. The one at the top looks different to the square wave at the bottom because the one at the top is connected to the gate of the IGBT, but the one at the bottom isn't. As you can see, I've disconnected it. Well, actually, you probably can't see, but I've disconnected the blue connector block. You might be able to see it there. Those blue things, I've disconnected one of them off of the RGBT, and I've taken it off so there's less risk of short circuit, even though I don't think, because these have got isolating pad between them, so I think I'll be able to put them on. I might just put that on now. Let's see, there we go. Now they're both the same. So let's test if it would short circuit the bridge. I'm going to put it, wait a sec, these are on 5 volts, this thing, oh yeah, that's still quite a lot, 5, 10, about 15 volts, and it's going at 182 kilohertz, and you could see it's almost out of the range of my scope, so yeah, this thing could go up to a megahertz. The resonant frequency of the Tesla coil is about 200 kilohertz. That's the big one anyway. The little one that I'm building will probably be about 500 kilohertz, so yeah, the scope would not be able to pick it up unless I do that, which looks a bit messed up, but then I do the times 5 and then you could see a high frequency, but it's not as good. There we go. But to test if this would short the bridge out, if 2 turn on at the same time, you do this, right, as you could see, as this is about half the way down, so it's still not turned off, this one goes up, so it could short it out, but let's have a look at, right, it's going to be running about 200 kilohertz, so let's have a look. Let's go 190, 212 kilohertz. What about, let's go crazy, let's put it up to like 500 or something. There we go, 497 kilohertz, that's what it looks like now. Let's feel the gate drivers. Stone cold. RGBTs are stone cold dead, it's just because the gates of them are running. These transformers are just a tiny little bit warm. I could literally just about feel that that's warm. Yeah, by the way, this thing takes 8 transformers to run it. The variac, that transformer, so I need it to drop mains voltage to, and I need the output. I need the input of these transformers to be 180 volts because I made a bit of a mistake, and the output of that would be, like, when it's rectified, it'd be like 28 volts, and these IGBTs are rated at plus minus 20 volts at the gate. I mean the thingy. So it could short them out. I mean, it could it could break them. So what I did was I have the 12 volt transformer going into this, and the input of this is normally 20. The output of this is normally 20 volts, but I'm putting 12 volts into it, so that's about half it. So I'm getting about 150 volts out going into these transformers. So now the output is 18 volts, and it won't pop it. Let's feel the resistors. Yeah, this is a tiny bit warm. I can't feel it low. But on this, it's not very clear, but I think it could you can still see it sorting out. But I'm still going to try it because it'll be current limited with resistor. So I'm going to put it on that power supply there, that transformer. This is another transformer. This resistor is 10 ohms, like loads of watts. You could have it on heatsink. It says 50 on it and 10, but it's 10 ohms, 10R, so it's 10 ohms, 5% tolerance. But it says 50 on it as well. It says WH50. So I'm guessing that if this was on a heatsink, it could probably take 50 watts. But if I put 10 volts into the bridge, that'd be enough to see if it's oscillating alright. And 10 volts going into this would be 1 amp because it's 10 ohms, and then that'll be 10 watts, and I think this would take it 10 watts without needing a heatsink, because you could get like 7 watt resistors that are ceramic that are smaller than this. So yeah, plus it's got a bit of a heatsink on the casing, but it's nowhere near as big as the massive ceramic resistors that exist. There's massive ones. But sorry about this video being really long, but there we go. Stupid trigger thing. But there you could see that when is this? Oh yeah, they're not. Right, that's separated. I need to be like holding this thing. Oh yes. Oh no, it's coming back. Right. Hopefully you'll be able to see the main part of that. That's the brightest. Now when that goes there, you could see that the part of this one, that when it turns on, when that turns on, the other one is still half on as well. There. So I think that first bit there, that first like lump, is where the gate drives are turning on because they're really fast, and then that lump there is where the IGBTs are turning on. So I think I might need more current. So the resistors are like that, limiting the current to it, but they're not very warm at all, so there's not much power going into it at all. And they're like 1 watt resistors, so I might remove those resistors. But I don't know if it's alright to drive these IGBTs with no gate resistor on them, because oh, what's going on there? They're going at the same time now. Something's messed up. Something's wrong. Turn it down. It's going alright when I turn the frequency down. It's at 200 kilohertz now, but you can see it's still inverted, so that's alright. I'm going to connect it now to the thing. There we go, that's right. But you can see it much better there. But when that goes over there, you can see both of them are on at the same time. It's bad, which would short out the bridge. And if you're running it like other people do on YouTube, like at 300 volts DC, that could be pretty catastrophic. It'd be a massive bang and the thing would blow up. But only the IGBTs though, hopefully, because the gate drivers would protect the rest of the circuit. Yeah. That transformer's rated at 2000 volts insulation, so, and these are rated at and that goes into here, which goes to those. I don't know what the insulation of these are, probably 500 volts or 300 volts or something, probably 600 volts actually, because the insulation on wire is 600 volts. But so there's 600 volts and then there's 2000 volts there, so 2600 volts isolation already, and that goes into those power supplies, so it should be pretty safe. But yeah, I'm really glad that that's working. Now let's try the other 2 channels on this side. Disconnecting this one. Disconnecting this. Feel how warm the transformers are. They're not even warm. So I probably need to remove those, like these are a tiny bit warm. Like these two here are stone cold, but these two are a little bit warm, so I think these two are the ones I was testing. Let's check that. That's actually wrong. These two here are on the other side here where I wasn't testing, so something might have gone wrong here. So let's test. Let's test to see if I just lost a tenner. I'm going to hook this up and then carry on with the video. Okay, the other side. So we tested this side. This was the first side we tested. This side, second side we tested, and the second side works fine. Still got the same problem, but they're exactly the same, the waveforms. So that's nice. Turn frequency up. See if we can get it to. There we go. Whoa, that looks really ugly. That's like a sawtooth. And then the zigzags cross over halfway. So that's basically a rough drawing for what they're doing. Basically, when one's halfway through turning on, the other one's halfway through turning off. So capacitance in the IGBTs needs to be lower, or I need to get rid of the resistors or put lower resistance resistors on there, and then that would make the gate discharge faster through these, because when these get a low signal and they're off, they short out the gate to the emitter, so that it discharges it. And it says in the datasheet of these, it stops the need for negative gate drive. That's where the gate gets sent a negative signal to discharge it, which is a bit more serious than just shorting it out. It actually pulls it instead of just shorting it out. I'm going to turn this up even more, see how fast the switching of this goes, and you can see the waveforms getting smaller, 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 and that's as high as it could go. Oh, you can still see rough triangles properly. There we go. Alright, and that is not inverted. If you could